Welcome back to Easily Explained, where today we will be talking about function notation. So let's get started. So sometimes it can be a little bit confusing to always refer to different functions as y is equal to all of the equations. It can be a little bit hard to distinguish among different functions, so we have a separate function notation. So let's say we are given the equation y is equal to 2x plus 7. So how do we write this in function notation? So in function notation, we have this specific way of writing it where we have f in parentheses, we write the x, and then just the normal expression on this side of the equation. However, the way we read a function notation is a little bit different. We read it as f of x is equal to, where f is the function notation name and the x is the input. So the benefit of using function notation is whenever you want to plug in a value for x, like an input, instead of, in this one, you would have to say like solve for x is equal to 2. But if you're writing in function notation, all you need to write is solve for f of 2. So you just plugged in the x. So f of 2 is equal to 2 times 2 plus 7. So f of 2 is equal to 4 plus 7. F of 2 is equal to 11. And also a thing to note is it doesn't have to be f. It could be any variable that names it. So if we're distinguishing two different functions, they might say like g of x, h of x, any letter you can write for the function name. So in the same way, when we were given an equation like y is equal to 3x minus 2, we could represent it in many different ways. We could have a situation, a table, mapping, or a graph, or just a list of ordered pairs. We can do the same thing for function notation. So taking this function, f of x is equal to 3x minus 2, if we wanted to draw a table, we would do the same thing by starting off with x values, 0, 1, 2, 3, and then making a column separately for the y or the domain or the range values. So we would plug in each number into x. So we would say f of 0 is equal to 3 times 0, which is 0, minus 2. So it would be minus 2. And then the next one, and all the way along. And from this information, we could also make a graph or map or any sort of list of ordered pairs. There's a bunch of different ways you can represent data. And for more information, you should check out one of our first videos, different ways of representing data. And for practice, we have two of solving for a specific function given the variable x, and two problems of writing a function either when given an equation or a situation. And keep in mind that you can write a function for anything, even if you're given a graph or a data table or a map. Okay, so let's start the first one. So we know that f of x is equal to 8x minus 15, and we're solving for f of 15. Basically means that x is equal to 15 in our case. So in the same way that we've done, we're just going to plug in x for 15 and then solve. So the first thing we need to do is 8 times 15, which is 120, and then subtract that by 15, and we get f of 15 is equal to 105. So in the same way, if this was just given as a regular equation, we would plug in x, and we would just get y is equal to 105. So basically the same process, is just a little bit different way to write it. And for number 2, same thing. We're just going to plug in the 2. F of 2 is equal to 30 minus 2, so it's equal to 28. And in the same way, if we solved it using y, we would just get y is equal to 28. Same answers because it's the same process. All right, now we have a little bit different problems. Write the equation y is equal to mx plus b in function notation. So just because it doesn't have an actual number value doesn't mean that it's going to be any different. So we're going to start with our f of x, and then we just plug in everything on this side of the equation. So you can think of this f of x as just replacing y in y is equal to mx plus b. And for the last problem, write the function for the situation. So now we have a situation. The horse gallops 15 miles an hour. So if it's easier, you can just think of the equation first, even though it's the same thing. So if we were to write an equation for this, we would first start by determining the slope, which is 15, because every hour the horse has galloped 15 more miles. So we know 15 is our slope, and we're going to say that hours are x. So our equation is y is equal to 15x. So now in the same way how we said the f of x just replaces it, all we need to do is write f of x is equal to 15x. Now if we go back to problems like the first two, we could be asked solve for 2 hours, and then we would say f of 2 is equal to 15 times 2, which is equal to 30. So in 2 hours, the horse would gallop 30 miles.
Congratulations, you are now an expert at function notation. We hope this video really helped, and we'll see you guys next time. Bye!